Okay, so as we march towards defining a generalized momentum that is invariant between coordinate systems that are moving with respect to each other at all velocities, not just at non-relativistic velocities, we need to go through some development of some mathematical concepts here. And what we're going to start off with is the concept of a scalar. So as I've written here, a scalar is a number that represents a physical quantity which is the same for any observer, no matter what their frame of reference is, nor their state of motion. So it's something that everybody agrees on. So what are some examples of scalars? Well, for example, the number of apples on a tree, for example, that this is something which every observer must agree on, no matter if they're moving or not, or how fast they're moving. Also, let's say the number of ticks by a clock. Okay, so we have to agree between different measurements that the number of ticks of a clock have to agree. Because, for example, we could, every time there was a tick of a clock, we could make a notation. We could mark something down. We could physically make a punch on something, or make a hole in something, or make a mark, and then we have to agree on the number of marks. Okay. We also know that the invariant interval, right? This is a scalar. It's totally independent of the reference frame. So remember, this is delta S squared, which we define to be okay. So that's independent of the reference frame. Something which we haven't talked about before, but the electric charge, see, on a particle is invariant. It's a scalar. And also something pretty important is the proper time between two events, if the proper time exists. Of course, we've discussed already how the proper time only exists between two events, only exists if those two events are separated by a time-like interval. So only if delta S squared is positive. Okay, so what are some examples of non-scalar quantities? Okay, well, we know the length of an object is frame dependent. Okay. The time between two events, just the normal time between two events, not the proper time, but the time between two events is frame dependent. And many other things. For example, the distance between world lines. Okay, that is not a scalar. Okay, so that's kind of gives you an idea of what a scalar is. Now let's move on to 4 vectors.